Let us continue our examples. I add another plane and I assign the material, and this time I'm going to create a hole on our plane as the detail. So the first thing I've got to do is to convert my model to editable poly and then get an inner inset from the mesh. And after I'm done with that, I will extrude my mesh down. You see how our shape loses its sharpness again and more towards a circular one. Here, not only the inner part, but also the outer parts of our model have gotten a circular shape. This is one big difference compared to the previous examples. So why has this happened? I say because of the inset. These diagonal edges that connect to our inner part result turbo smooth to redirect and count as if it's a circle shape. But as you see here, we do not have such lines and edges for the turbo smooth to do something other than regular edge loop. Now, not only we have to correct the inner extrusion in the inside, but also our plane's corners on the outside. Now I enter editable poly to be able to ring select the outer edges. To do that, select the edge, select ring command to create an edge loop, and thus redirect the turbo smooth behavior. I do this one time for here, one time for the corner, and for the bottom part, I use chamfer to make a little transition between the surfaces and not have the edge loop on the flat surface. So now I think that we've worked enough with Swift Loop and we know how it should work to help us limiting more edges. I want to now test Turbo Smooth and to see if we're on the right path, and I think so. See, the oval shape we get now is being kind of limited by the edge loops we inserted. Just like before, I want to turn this fillet corner here to a more sharper and defining edge. With double click, I select the loop and control remove to see if it's enough. But quickly let me undo and first create more distance between my edges using edge sliding. I set my constraint to edges and move my edges now a little bit further. Now I delete the middle edge to get this chamfer effect that we've been getting throughout this tutorial. One thing to do now is to chamfer my main edges again here to preserve the overall sharpness even more. I turn on Turbo Smooth and there we go, a nice chamfer preserving the sharpness of the corners. Next step is to control and actually redirect the outer, or better say the corner part of our model. So I convert my model to edit poly again and enter quick slice mode in this slice plane mode. I want to cut some lines onto our mesh like this on the top view. Note that I'm not being accurate, I'm just cutting some lines around the corners to show you something. I turn on Turbo Smooth and now take a look. It is in fact limited and not circular, but again it's completely messed up. But if it's not the way to do it like this, so you might ask how to fix this then, I say we should first delete the lines, but double clicking and removing. Instead of using this diagonal line, I add 2 edges using cut command and manually trace the straight lines of our box and connect them to the corner. To remove this extra edge only without the vertex to mess our model like this, now I should use the remove command instead of delete. And by this way, I finish fixing this part and see that it's been fixed and there's no more circular shape on the corner that we worked on. So the key here is to maintain 90-degree perpendicular lines and avoid also, of course, the triangles. Now, I'm going to repeat the same exact thing for the bottom part to then use symmetry and finish this example for you. Now, instead of repeating the same thing on the other side as I said, I will use symmetry command with low threshold and then put turbo smooth on top of symmetry to make it work again. Now, pay attention here. Notice this vertical line here. Let me show you. If you take a look, we don't have circular shape anymore. It's more like a boxy shape with a round corner, and it's because of this symmetry. When we do symmetry on our mesh, the symmetry line itself on the middle of the mesh will interfere with what we want to achieve. It's being applied completely on its own. So for this thing, you can simply keep the symmetry and turn the mesh to editable poly again and just delete the symmetry line. Now see, back to circle shape all over again. Just remember, whenever you have diagonal lines or triangles, pay close attention to them and what you want to achieve. Sometimes you may want to keep them, but other times you should be able to spot them using the hard surface material and just try to fix them in a way that suits your situation better. Now, I'm going to repeat what I just did here quickly to show you something else. Look, we said that when we apply turbo smooth, we get a circular shape, right? As we did before in our example. And we fixed the corners and changed the diagonal lines to perpendicular lines, maintaining 90 degrees, okay? But it's good to note that this distortion or this, circular shape only happens when our shape, or better say, the corner verts are free. I mean, they are not connected to anything else. Let me show you an example right here. If we copy our mesh and put them near each other, attach them together, and press 3 to activate border mode and control vertex to weld them together. Now you see only the corners that have not been connected to something else are circular now. And when we limit the corners by connecting them to other things, they won't get distorted easily. So it is good to keep in mind that you might not need to change the topology on each side of your mesh every time you're working on an example or on a topology. It's good to note that nothing will work everywhere. Now let us move to another example. Here, from only working on flat surfaces, let us see how holes, as details, work on curved surfaces now. So I will create a plane for this demonstration, and just as before, I assign the material and I convert the model to editable poly And then, to make it as we want, I will extrude it for a couple of times to make the shape that we desire. Now, I want to put 2 edge loops in the middle of our mesh that we just created using connect command that I showed you. And then I will select the top and bottom part and insert another edge there too. First, let us turn Turbo Smooth and see how it looks like now. Just as we expected, a wavy surface for us to work on, right? But we do not want this exactly, right? We want sharper edges. We use the tools we just learned earlier to get what exactly we are looking for. Now I start to select the faces that I want to create a detail like a hole in here. I'm going to select only the middle parts to show you how it's like on these types of surfaces. So I extrude the faces in to show you what happens now. There's going to be a problem. If you take a look, you see that extrusion itself has worked fine, yes, but because of the angle that we're on, all of our edges, even the last ones on the top and the ones on the bottom, are being diagonal too. They have the angle to them. So the thing is, we have to manually put them in the place we want. Let us turn on Turbo Smooth and see. Turbo Smooth is working as expected. Now, let us see. I believe our corners need to be a little bit sharper, and there is extra roundness to them compared to the reference. So we go again to our Swift loop in the edit menu, and with that tool, just like before, we want to limit Turbo Smooth behavior to get more sharpness. After the changes we did, turn on Turbo Smooth again. Now it's good in this section only. Let us now start applying the same principles to the other parts and to the other angles that we have. So this is better. We sharpened these parts and it's looking pretty well. But now we have to do this process on the outer parts to prevent a shading effect that we're getting because our topology needs something. The thing I did was to, well, limit the edges to preserve the shape from Turbo Smooth. And that's what we're going to do for these two parts again. But this time our purpose is to eliminate the shading, the bad shading effects on the model. Now, I want these parts to have chamfer, and exactly as I said, I will select these parts and edges and then give it a chamfer modifier and do that. Also, from the previous examples, now I think we have learned it's good to repeat chamfer modifier again to preserve the original chamfer that we did to even more preserve the edges. And with that, I think the corners are also pretty well. Up until now, we have learned many forms and how to approach them, how Turbo Smooth works, and even what Turbo Smooth is. But now we want to go and examine one of the problematic surfaces, creating circles and maintaining circles. In hard surface modeling, a circle can be created using a variety of ways. But the most prominent thing here with circles and creating them in hard surface models is that octagon is going to be most of the time our go-to shape because it's only 8 edges and has 8 sides. It's easy to control and so efficient for Turbo Smooth to be softened into a circle. I'll show you now. So I add a plane like this and I will set the proportions to both in 80 centimeters to get a square, and then I convert it to editable poly. And now I want to create 2 edge loops with connect command, and to finalize and make it a circle, I'm going to connect every vertex of our square to the vertex in the middle one by one. And finally, after that, I chamfer the middle vertex to get my octagon. I only need to remove the surface of this face that is selected. You will see as I apply Turbo Smooth, I will get the circle shape I want. So you should remember, whenever you want to create circular holes, you can easily do this by adding a vertex in the middle, and then what you do is to chamfer the vertex to get the n-gon. Let us now model something a little bit more challenging. We have learned many techniques to now model some kit bash parts from the reference. I choose this one, which has 2 holes. For now, I want to model this part in a more simpler form without this rounded curve. So I use a cylinder, set height segments to 1, increase the overall property of height, and also increase the cap segments to 4. And not to forget, it should be an octagon, and we can do that by setting our sides to 8. This way we have manageable geometry to work with. I select this round edge by ring command and use chamfer to make it into 2 edges. Then again, I select this round face and extrude it downwards, and later I will come back and chamfer these edges also. So let us now work on the circle. Which circle shape? Those on the sides that you see in the reference. So the thing here is that they're not going to be easy as the other parts that we did just now. The simple way to do this is to do it on one side and then just, do the symmetry. I now want to add an n-gon and be sure to set it to 8 sides, and pay attention, I must make it bigger than the original shape I want, and I tell you why. Okay, to something like this. Now, pay attention that this shape right now doesn't have anything to do with our hard surface model. It's just a simple spline shape flying over our hard surface model. Now bring it up a little bit. So you have to return to your model now and pick up the cut command, and based on the octagon verts, based on our 8-sided shape, you must cut the geometry and basically copy the shape of that onto your hard surface model. So basically I'm just using this n-gon shape as a base, or better say as a reference, to be able to cut this exact shape onto our mesh. Okay, I think we're good now. The thing we have to do here is to remove first this extra edge, and then by using weld operation, add some edges to the right positions and not let any vertices float without connection. It's so important. Remember, when I said consider the n-gon a little bit bigger, it was because we are going to inset from it one time and secure this area. Now, to be more clear, I'll show you what happens if we don't do that in just a second. I will take a copy now from our model and add the hard surface material to it. But first, let us continue with the correct model and the one with the extra inset. So I add an inset inside and then I extrude downwards. Now, I give it the turbo smooth command, and very well. You see, it is in fact clear and good. Now, let us see what happens if we do not secure our extrusion with a safe loop. I extrude this down too, okay? Give it turbo smooth command, and pay attention how everything is distorted and shaded different. I'll give it more depth for you to see. It's not so round and clear. Just compare these two. By adding a secure loop, the point is that by adding a secure loop, we restrict turbo smooth operation to work properly and not affect where it might cause us problems. So finally, I adjust it a little bit further, and to finish this session, I want to make a symmetry from this hole. And the first thing to do is to apply the chamfers to the edges. You remember that we have to do this operation twice to have the details preserved well and get the preferred sharpness that we want. The only thing here is that the distance between our holes is more noticeable than the reference.